Okay, go ahead and head over to lab 7. Ooh, that's nice and big. Okay. In this lab, we're going to practice using virtual functions or virtual classes and deep copying. Hopefully with lab 6, you've already done deep copying, so this should be a lot of copying, pasting from your previous lab, putting it into this lab, but making it work using virtual classes. So keep in mind that this lab is unique in that we're only going to do it this way, this one time, and then we're going to jump over to generics next time for your next lab, which looks like we'll get to today. But the point of that is this is the only time you're going to see this. So get this done, make sure you understand it, and then we're going to move on to something else. So list.hpp, this hopefully sounds familiar. With Java, did we do a list interface and then implement it with some type of data structure in OOP when I did that last semester? I don't remember. DJ?
Say it again.
Did we have a list interface and then implement the list interface with something last semester?
I think so.
Think so? Okay, good. Can't remember if we went over that last semester or not. All right. So class list, public, hey look, virtual index of, virtual remove, insert, get, set, and equals. These are virtual functions, so that means that the list class is purely. Can we instantiate a list object? No, so it is abstract. I have already stubbed out the code for this. Isn't that nice of me?
It is.
So if you look inside Lab 7, we have right now 4 files. You put in your look in your src, you can have a list.hpp. So we're going to look up vim src list.hpp. Hey, look, here it is. Class list, virtual, etc., 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 and then we're done. All right. Now now you're going to create an int-array class that implements list and utilizes deep copying constructors. Okay, so I am not giving you the header file for this, so you're going to have to come up with that yourself. This is probably going to be the tricky part for you, is how do we actually come up with a header file for the int-array class. If you haven't been able to pick that up from previous code in this class, what we're going to get to next with generics, it'll become really obvious how you write header files. But you're going to write your own int-array class. I highly recommend creating a separate int-array header file and then it's your own int-array CPP file, although you don't have to create a separate header file if you don't want to. But I highly recommend it. Okay. Let me look back, or actually, let's not look at that. Let's look at the code and see what's going on here. So here's an example code that should help drive what the int-array should look like. In reality, the int-array just inherits from what's above, plus it's going to have a deep copy constructor, meaning that it can copy, just like beforehand with Lab 6, from an array and a value being passed in of its link, and from another int-array class. You can see that on the second and third lines here. All right, so first off, have an array, gave it some values. The next one, what is that next line doing? Let's see if we can remember. Yeah, the second line, right here. Technically line 41 by this slide. What's that one doing?
It's creating a pointer that's pointing to an int-array pointer.
It's creating a pointer that points to an int-array. It's not a pointer pointing to a pointer, it's just a pointer to an int-array. And we're calling that pointer ARY1, and then what happens next?
The next line.
No, still on that line.
Okay, so
We've declared an int-array pointer
creating array on the stack on a heap.
on the heap, correct?
With a size of 5.
Size of 5, and its default values.
Like it's will be defined at the time.
All right, very important. It's created on the heap, and it's a deep copy, meaning it's creating a separate copy of the int-array memory out there, and then copying the values over. Make sure you do create a separate Copy, otherwise your code is not going to pass the test cases. Yes?
One thing I did in the last lab, but I didn't fully understand, is why do you have to have the star before the name of the enter array?
To declare it as a pointer.
Okay.
If you don't have the star, then it's not a pointer. It's just an int array
But
object.
you could create a variable without the star.
Correct.
It is an int array.
Yes, then you're creating it on the stack.
Okay, okay. And then you couldn't do equals new something.
No, you cannot.
Okay. So the pointer lets you be able to create over heap unless you create a new passing something.
Yes, it does allow that. More importantly, more specifically, you're creating a pointer, and then you're afterwards creating an object on the heap. So now you have the int array object on the heap. What's the last thing that it does? That this line does? You declared a variable ARY1 that points to an int array. Then you create an int array object on the heap. You called its constructor, passing in a standard array and a size of 5, so that internally your code should actually create another array inside the heap, size 5 with those values. So it's created that object. It has on the heap and has a variable called int array that is of type. You have a variable called ARY1 that points to an int array, and then what's the last thing it needs to do? What is it storing?
The pointer?
The pointer is storing the memory address of the int array object. Okay?
How come when it's copying the int array, it has 5, but up top it only has 4?
That's a terrible error.
I was just thinking maybe
That would
So
give
that's
you an error.
Terrible. No.
Would it?
No.
It would just fill in a random one?
Yeah, whatever's over here after that 20 in memory, it just copy over.
Oh, okay.
It might give, well, actually I should say, the behavior is undefined.
Okay.
It might give you an error, but it probably won't. It's C++.
That's very true.
It's fine. All right. Now, what's this next line doing?
Creating another pointer to an int array on the heap that points to first pointer.
Okay, hold on. So the first part you got right, ARY2 is an int array pointer. We're declaring that there. All right. Then what happens?
And then it creates a int array on the heap
Yes.
that pass pointer array 1 or array 1 pointer.
So you're not passing in a pointer. What's
you're passing in the no, you're passing in like the array and 5, right? Or no, you're passing in int array, the other int array.
Yeah, you're passing in the other int array.
Yeah.
This means dereference.
Yeah, dereference.
So it's going to go to this memory location and pass it in there, and pass the actual object in. Okay? So make sure you pass that by reference. All right. What should this constructor do then?
And just copy it, right?
Right. It's going to create its own internal array.
Oh, so
copying.
this be like a deep copy then, kind of?
Yeah, deep copy. So these two objects, should they have internally the same values? Yes, good. All right. So ARY2 has been declared as a pointer to an int array. You create an int array object on the heap that's a copy of ARY1, and then you
I was reading the rest of the code.
and then you store
The int array on the heap. Values.
you're not storing the int array on the heap. What are you storing of the int array on the heap? I'm not on the heap, on the stack.
The array. On the int array.
What is new return technically?
Memory location.
Memory location. So you're storing that memory location inside of ARY2. All right. I'm trying to be very verbose here to help you out because you're going to get a lot of pointer problems if this is not clear. All right. what should this line of code print out?
Memory address?
Should print out. Should be true.
Why is it not true?
Because it's their memory address.
Because you're comparing memory addresses of two separate objects. So this should print out a false, which I can't remember if it was 0 or 1.
Zero.
Zero.
It's 0? Yeah, it's 0. Hold on. Yeah, it's 0. It's 0. Because not 0 is always true, so then you, inside of most architectures. At least on x86. Okay? Everyone clear with that? Remember, that's how Java worked as well. This is why. All right? How about this one? True, because you're actually calling equals, and you're trying to see if the two internally are equal to one another. So this should return true, or 1, or whatever value needs to be returned, which should be 1.
You were talking last class about that arrow replaces the, like a dot. You know what I'm saying? Like in Java or something, you would say like area 1 dot equals, and that arrow replaces it because it's a pointer?
Correct.
Okay.
All right. May not remember what this does, so we'll scroll back up. Set sets the element at position posed to the value val. So, in other words, at position 2 should be the value 10, so 0, 1, 2. So this 34 should go back to a 10, or should be changed to a 10. So now if we call dot equals, what should we get back?
False.
All right. And what is this one doing?
Send it back to
34, which means that this is,
True.
all right. Any questions?
On the lab where we had to delete a index of an array by shifting everything down, what were we supposed to do with the last index?
You wouldn't have to do anything. You decreased your size, right?
No.
Well, like I got a 0, but I can.
I set the last value to 0.
I mean, that's fine.
Okay.
Well, I looked it up and people were saying you could use vectors, but I assumed
No vectors yet.
no vectors.
We'll get to vectors. We're trying to get to vectors. We haven't gotten there
That's
yet.
what makes everything easier.
I don't know if I completely agree with that. I'm going to allow you the option to use
vectors.
vectors.
use vectors, so let's do the easy way. Okay. That's stack
It's-
overflow.
Those people don't know what they're talking about.
It can be easier. I'll put it that way.
Yeah, Stack Overflow, we only use vectors.
Is that their voice?
Yeah, I think so.
Yeah, that's pretty much the voice I read.
You're a bad
Well, you have
programmer.
to do this
Yeah,
first.
you're doing this completely wrong. Let me tell you why.
So it's due September 25th, which should be a week from today.
Yeah, that's my birthday.
Oh, happy birthday.
Oh.
You'll probably get 2 labs.
It's my 21st birthday too, so.
Oh, wow. All right. So, doing a week, ensure you push all your files, make sure you test it. No teamwork. Do not use the STL. I'll tell you when you can start using the STL. That's not yet. There's the webhook. Hopefully the webhook's been working for y'all. I looked at it.
Nope.
Looks like it was. Was not working. When did you try last?
I tried to use it for both the most recent labs.
When did you try last? What day?
Whatever the day the last one was due. I guess it was Wednesday.
Wednesday? Yeah, it was probably still down that day.
So
Yeah,
are we supposed to be using the auto grader then for this?
you do not have to,
Okay.
but
I should.
you should.
The autograder.
Wait, hold on. Let me rephrase that. Let me make this easier for everyone. Yes, you have to be using the autograder. Everyone got that? Hook up the autograder. If you're not using the autograder, I cannot guarantee I'm going to grade it. So there.
The autograder was down both of the days the labs were due.
Yeah, I haven't graded the lab yet because of that. So you've implicitly had more time. But I'll be getting to that today. Okay. Any other questions about this lab? No more questions?
I actually do have a question. So we're creating a header file with virtual functions. Is that?
I've already provided you a header file with virtual functions. So when you create a class, you're not going to put in virtual functions, you're just going to implement them.
Just different functions.
Any other questions?